Okay, back where we left off, we've got this question that in setting up a resonant frequency in a tube with a loudspeaker at one end, the longer the tube, the lower the frequency, the lower the resonant frequency will be. Why is that? So let's just think about it. This kind of basic physics, or maybe even hopefully common sense, that we have to wait when we're emitting pressure pulses out of this loudspeaker. We have to put one into the system. It goes all the way down to the far end and bounces back. And if we are going to set up a resonating pattern or a standing wave, we have to wait for it to go all the way down the length of the tube and come back and then push again. So like I said before, we're going to hold the speed of sound constant when we do that. So if all we're changing is the length of the tube, when we make a longer tube, we just have to wait longer for the pressure pulse to go all the way to the far end and then bounce before we push again. So if there's a longer period between pressure pulses, if remember frequency is the inverse of period, then we're going to have a lower frequency. If we have the shorter tube, it's going to bounce back and forth more quickly. We have to push more often. And when we're pushing more often, when we're sending in pressure pulses more often, we have a higher frequency. Higher frequency just basically means more often. Lower frequency means less often. I'm going to try to do this with the slinky. We'll see how well it works. But this is about a reasonable length, so I hold it relatively tight. I put a pressure pulse in, and I'm sort of reinforcing it at this rate. Focus on my right hand here over to this side. How often am I pushing? That's the frequency of the resonant frequency. If I lengthen this thing out, it takes longer to go. I didn't want to change how many coils I was dealing with there, but if it has longer to travel, I'm pushing a little less frequently with my right hand. That resonant frequency is a little bit lower in terms of hertz. Okay, and it's all just based on the length of the tube, basically. Okay, so I'll give you another demo. This is not totally analogously appropriate, but I'm going to do it anyway, just kind of give you a sense of what this sounds like. So I did the pop bottle blowing demo before. Sometimes this works better than others. Let's see if I can get it to work. So that's sort of the resonance you get out of this one. And what's resonating again here is this little empty space here. And I know I'm going to post this to the internet, so wise people out there will know it's more complicated than that, but you can think of it as this is the part that's resonating. It's a short length of a tube. If I try the other one, I'm not very good at this. But for some reason, that never deters me from trying. But this is the sort of resonant part. It's a longer length of a tube, and that's going to give me a lower frequency versus... All right, I'm going to pause with the pop bottle stuff because sometimes it works, sometimes it doesn't, but I'll record those later and show you what it looks like in a spectrogram. To relate this to speech, we need to add two different elements to the theory. So first of all, which makes something that makes this interesting, but also unfortunately a lot more complex, is that you can have sound waves of more than one frequency resonating in a tube at the same time. And then the vocal tract is a tube that is open at one end. And speaking of open, I'm going to close these pop bottles before I knock them all over the floor. So the vocal tract is an open tube, so it's going to behave a little bit differently from a closed tube. And I'll explain what that means in a second, but let's go over this first point first. So it's possible to set up more than one standing wave in a tube at the same time. And when I do that, basically to get more than one resonance, all that I need to hold constant is kind of what's happening here at the end where I have the loudspeaker. Scratch that from the record. This is what it looks like if I have what's called the first resonance, or sort of lower frequency resonance. This is kind of the alternation between high and low pressure I get at different points in the tube. If I have a second resonance, it might look like this. So the question I have is, will the frequency of the second resonance be higher or lower than the first? I'll let you think about that for a second, and then I'll give you the answer.